Hello, my name is Paulo Lourenço, and today we are going to see a demonstration of magnetic levitation. This video will have two parts. In the first one I will be explaining the concept, and in the second part will be a practical demonstration of magnetic levitation using diamagnetic properties of graphite. Graphite is a form of carbon, and we will use it to levitate a small magnet. The device is a wooden frame that has two graphite plates. We have a screw, and this screw moves this magnet within this space here. I made a drawing of this part of the device and to show how the forces come together to achieve a balance between these two plates of diamagnetic material. So we have a magnet. The first force that we have is the force of gravity. We will call it Fp. The other force that we have is the magnetic force of the magnet that is above. They have opposite poles, so we have a force upwards, we call it Fm, force of this magnet. If these two plates were not here, as soon as the magnet starts to go up, it will go fast, and because of the magnetic force of this magnet increases as the distance becomes smaller. So if this moves a little bit, the magnetic force of this magnet increases a little bit, and it's a positive orientation. So it starts to go up, it goes all the way up until it reaches the magnet. In the opposite direction, if the magnet gets a little bit lower, the magnetic force is smaller, and the weight of the magnet falls to the ground. So the only way we can have this magnet in equilibrium is by adding these two plates of diamagnetic material. How does that work? When the magnet starts to go up, the magnetic forces increase, but the diamagnetic materials repel all magnetic forces. So this plate, G1, will exert a force downwards like this. When if the magnet goes down a little bit, the magnetic force of this plate, the diamagnetic properties of this plate will repel the magnet up. So we have another force here. We have to achieve the balance between these four forces, and that is when we reach this point. This force plus this force, the repulsive force of the given plate, is equal to these two forces, the magnetic force and the repulsive force of the bottom plate. When the magnet gets a little bit up, this force increases, but given this force increases also. So this is stable all across this space here. It doesn't have to be in the middle. It can be stable closest to this plate or closest to this one. This expression is true in this space between the two plates. Now I will show you in the lab this device and how it works in reality. We are at the lab. I have here the device that I showed you in the whiteboard. It's a wooden frame. It has two graphite plates, and between I already placed a magnet. The magnet is in the center. It's touching the bottom plate of graphite, and now I will move the screw slowly so it will be attracted strongly by the magnet above, and it will be floating in midair. Is already floating. Now I will zoom in. I will stop the video and zoom in so you can see clearly that is floating and not touching any of the parts of the device. Now I have zoomed very closely to the place where the magnet is between the two plates of graphite, and we can see that it is levitating. Even if I touch it, it doesn't go anywhere, it doesn't fall, it stays in place because all four forces are in equilibrium. The magnetic force of the magnet that is above in the screw, the weight, the force of the gravity is pulling the magnet down, and the repulsion of the two plates of graphite. And when these all four forces are in equilibrium, the magnet stays floating in midair. And this is a demonstration of the diamagnetic properties of graphite. I hope you enjoyed this video. I will try to make some more about diamagnetic properties of materials. But for now, I hope you have liked this video. See you next time. Bye.